In this lesson, we're going to be looking at representing patterns. So first, we're going to evaluate each expression for a algebraic equation when x is equal to a certain value. When you're given questions like this, what you want to do is take the value that x equals and plug it in or replace the x variable, or whatever variable you happen to be working with, in the equation with that value. So here I have 2x plus 1. So 2x plus 1 is 2 times x, and then I'm going to plus or add 1. So 2 times x, which is now 3. So I replace the x with 3, and then add 1. And then I just do the order of operations to evaluate this expression. So 2 times 3 is 6, plus 1 is equal to 7. So it's just a matter of replacing that variable with the value that it equals. Let's look at a few more examples. 3x minus 4, I'm going to evaluate this expression when x equals 2. So this x equals 2, this value of 2 is going to replace the x value, just like the 3 in the previous question replaced the x value. And the way I write it is 3, because this is 3 times x, I write 3, bracket, 2, which means 3 times 2, minus 4. 3 times 2 is 6, minus 4. 6 minus 4 is equal to 2. Notice how I'm using my order of operations as well, doing the brackets, doing the multiplication, before doing any of the addition and subtraction. And usually I put a box around my answer because then it makes it really clear what the answer is. Next one, again, x equals 7. My expression is x plus 10. So this time I have nothing multiplied by x, but I'm still going to put it in brackets just to remind myself because I'm replacing the x with 7. And that's 7 plus 10. This is 7 plus 10. It's not 7 times 10. The only way you'd have 7 times 10 is if your 10 was right next to, if your 10 was right next to the 7, right? That would be 7 times 10, but that's not what we have here. What we have here is 7 plus 10. And 7 plus 10, of course, is 17. So just be aware of that. Sometimes you won't have a value, a coefficient that's in front of the variable multiplying. The last example I have here, 2x minus 3. Again, I'm going to take that 6 when x equals 6. I'm going to replace it with my x, or replace x with 6. So I have 2, bracket, 6 minus 3. And 2 times 6, of course, is 12. And 12 minus 3 is 9. Okay, so just very simple equations. Replacing the variable with a value and then evaluating the expression. Let's move on. Now we're going to get into table of values because this whole section kind of progresses to this idea of table of values, equations, how it relates to graphs too, even like line graphs. But this is just the very beginning. So this is kind of the beginning lesson. How to evaluate expressions when I'm plugging in numbers will lead right into creating table of values, which will lead right into creating equations even and graphing them. So create a table of values. So we're going to look at what a table of values is. So table of values is also sometimes called like a T chart, or because it looks like a T. And then what I do is I look at the first column, which could be the figure number. That will be the figure like number 1, 2, and 3. So this will be my figure number. And the next column will be the number of squares. Sorry, my pen isn't working quite right. So the figure number is just going to be 1, 2, and 3 in this case. I only have 3 figures. And the number of squares, in this case, you can just count them. So in the first one, 1, 2, 3, 4, 5. There are 5 squares total. The next figure for figure 2, 1, 2, 3, 4, 5, 6, 7. You might see a pattern already. And figure 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm just counting the number of squares in each figure. Sometimes you might be given a triangle. I don't know. And what we want to do is we want to look at the table of values now, and I want to look at the right column and ask myself, what is this going up by every single time? 5 to 7 to 9. It's actually going up, not down, so up means plus, and it's going up by 2 every single time. Okay, so if I was to write figure 4 in here, we might be able to estimate, but with a pretty high degree of accuracy, how many number of squares there would be, because we know as the figure number goes up, the number of squares goes up by 2. So if I add 2 again, then my number of squares should be 11. So if I drew out figure 4 with all the squares, it should be 11. And I could continue going on this pattern up forever, really, because I already know the pattern. I know it's going up by 2 every time. If you have like 3 numbers is really, it's kind of the minimum you need. It's not a great indicator, but it's okay, and it will tell you, it'll show you the pattern. So this is creating a table of values. How to create a table of values, like a T-chart. You have a left-hand side and a right-hand side. We'll see as we move on, as we did above, where we had like X's and Y's. You're going to be writing a table of values with 2 variables, one on the left, one on the right. In this case, I had figure number and number of squares, but typically you'll have X and Y. Okay, so how does an equation in a table of values relate to the numbers for X and for Y? So we've already seen how to plug numbers in. So it looks like a lot of information. Let's just break it down. Let's just do part A first, just this first one. So if you can see, the first line on each one of these has a 0 for the X. And remember from the first example in this whole thing, you take the value for X, you plug it in for X, and you see what you get out for Y. That's essentially what you're doing for a table of values. You're plugging values into an equation and seeing what you get out, just like we did in that first example. So when I plug a 0 in, I get 3 times 0, which is 0, plus 13, which is 13. That's how I get that first value of 13 in the table of values. When I plug a 1 in, these are already shown for you. You don't have to do these. I'm just kind of walking you through how these numbers, how they came up with these numbers in each one of these sets. So when you plug a 1 in, 3 times 1 is 3, plus 13. 3 plus 13 is 16. 2 times 3 is 6. 6 plus 13 is 19. So we can start to see the pattern, and this is what we're going to be looking for. Each time, what is it going up by? And that's how these will all, what is it going up or down by? In this case, all of these are going up. So every time these are being increased by 3, every single time, I'm adding 3 each time. How does that 3, or where do you see that 3 in the equation? Do you see it anywhere in this first equation for part A? I can see the 3 right there. Right? Right in front, the coefficient, what we call the coefficient, the value, the number, in front of the variable. The coefficient in front of X is 3. That 3 in front of X, that coefficient, is directly connected to how much the table is going up by each time. Okay, so we're going to have to work backwards eventually, but what I'm trying to get you to see is where these numbers come from. There's the 3, directly connected to this 3. What about this 13? Where do you think that comes into place? Well, I can see a 13 right here. And notice that 13 appears when X is equal to 0. Notice over here when X is equal to 0. Notice over here when X is equal to 0. What value do I have in the part B? Well, I have an 18. Where does that show up? Oh yeah, the number by itself over here, which is called the constant. So the constant value in each equation seems to be when the X value is equal to 0. Similarly over here, when the X value is equal to 0, I have a Y value of 15, which shows up right there. And you can even test. When I plug a 0 into X, for each one of these, 7 times 0 is 0, plus 15 is 15. Same thing over here. 11 times 0, that's 0, plus 18 is 18. So directly connected. Those two values are directly connected. When X equals 0, you will have that constant number by itself in the equation. And the other value that's in front of the X, the coefficient, should be the number that it's going up by every single time. So let's check. 18 to 29, yeah, that's plus 11. 29 to 40, that's plus 11. 40 to 51, that's plus 11. So the 11, the value it's going up by each time, represents the value, the coefficient in front of x. The number, the value for y, when x is 0, represents the constant value on its own. So we're going to have to come up with equations on our own. So as long as we can see the pattern, we should be okay. And you can look at x as well. This is, again, going up by 7 each time. And we can see that the value when x is 0 for y is 15. So y is 15 when x is 0, but that also represents that constant number on the end for part C. So that was just a kind of investigation to look at. Okay, now let's try and come up with our own equations based on what we just did, our own equations for the following table. So I have a table of values here. I have values for x, values for y. We're not given the equation, but I know that the basic form of the equations in this course are going to be y equals something. Here, let's use, I don't know, boxes or something? Something x, that's confusing. So we're going to have a value in front of x, and then plus or minus, it could be minus 2, we'll see, some constant value. Now, what value goes in front of the x? That was the number that it's going up by every single time, right? Maybe it's easier to fill in the final value first because we know if x is 0, that final value will be that y value, which is, in this case, is 3. Okay, and it's going up, so yep, we can even just put a little plus over here to remind ourselves it's going up. So it's going to be plus 3 because it's going up, and the coefficient in front of x is what it's going up by every time, not plus 3. It's going plus 7, yeah, good, plus 7. So the value in front of x will be 7. So we finally come up with the equation, y equals 7x, that's where the 7 came from, plus 3. The 3 comes from when the x is equal to 0. Let's do a couple more, and then we'll be done with this lesson. See if we can find the patterns here. So I'm going to start with my equation, y equals something x, something times x plus something. Okay, so what is this going up by every time? 12 to 14 to 16 to 18. That is going up by plus 2. So that's the value that goes in front of the x is a 2. So I get y equals 2x plus, and then the constant value on the end, remember, is the value when x equals 0. So when x equals 0, we have 12. And it's plus because it's going up each time. So plus 2, or 2x plus 12. Or sorry, this value of 12 is positive because the value of 12 in the table of values is positive. This value in front of the x is positive because it's going up each time. So this example will be when it's going down. So again, I start with y equals something x plus or minus something. The value when x equals 0 is 2, positive 2, so that's going to be plus 2. And the value in front of x, let's see what it's going up or down by. This time it's going down because 2 to a negative 8 is a drop. And it's a drop of 10. And each time you can see this is going down by 10, down by 10, and so on. So that means the value in front of x is going to be a negative 10. So y equals negative 10x plus 2 is the equation that fits this table of values. Remember where each piece comes from. The number in front of x comes from the number that's going up or down by. If it's going up, it's plus. If it's going down, it's minus or negative. And the value on its own, the constant on the end, comes from the value that is on its own when x equals 0. Hopefully that helps. If you have any questions, maybe go back to the beginning of the video and just kind of review. Yeah, and let me know if you have any questions.